Okay, so during the last few weeks, we were looking at an introduction, and also we looked at what are the areas that we'll be covering under software quality assurance. Now, today we have a few more things to discuss as to what is testing and what is not testing. Plus, how do we go about looking at testing? Also, what kind of job opportunities are there when it comes to software quality assurance? So it's not just testing, but it is software quality assurance. So it's a larger area than just testing software. Okay. So before we get to the job opportunities, let's look at some of the techniques under this SQA area. I'll also would like to take you through the LMS because I've loaded some things. There are some videos, some very important articles. I think apart from my lectures, you should also have a look at those. Right? They give you additional information to the area. Right. So from the continuation of last week, who should do the testing? Right? Whose responsibility is testing? Because we discussed there are programmers who write code, and then there are actually we go further down, right? So there is marketing team who bring the business to the organization. Then we have the business analyst who will do the analyzing part. So they sit with the customer and the development team and then try to understand both sides. So generally they first meet with the company and then understand what kind of problem they have. And they translate that to so that the developers can understand what the problem is. And then we start coding. Okay. So we also realize we don't start coding immediately. We also incorporate another team. Apart from the BA, we also incorporate another team. This is the quality assurance team or the testing team. And then we plan our code. So basically we do things like architectural planning of the software. I think that's where we decide like what language, what frameworks, what kind of user front end, back end technology is going to be used, things like that. And then along the same line, we will understand how the QA team can help the development effort because we realize that V-shaped thing, right? Where testing happens from step one, not after the coding. So there are a lot of things we need to make sure. For example, there's dry testing, realizing how the BA documentation is properly understood by the coding, right? So, and the customer. So we even verify that. So department of QA requires to verify there because if we have not captured what the customer want, we may be building the wrong product. So they need to do some sort of validation process there. So remember we talked about V&V, validation, verification, right? So validation is where we validate our understanding. Are we building the right product? Yeah. So as this slide says, testing start right from the very beginning. Number one. Number two, it is everyone's responsibility, right? Not only the coder. So we can't put the blame on the coder. If the product is not working, it might be due to two parties. QA not testing done properly, and then developers may have introduced bugs. Introduction of bugs is natural. I mean, it happens all the time. There are no programmers who write complex software without introducing any bug. Almost impossible, right? Almost impossible. So next question is, okay, first question, who's doing the test? There is also another very valid question. How much to test, right? Now, what does that mean? How much to test? Because there has to be a limit as to how much we can test as well. Or should we, is there a stopping time? Is there any time where we stop testing, right? Now, just to show you an example, look at this calculation. This is a very basic calculation. So what you're trying to do here is, okay, let's say there is a loop that is that has three components, right? There are three things that is going on. So if you run this loop twice, if you run once, it will go 1, 2, 3. If you run again, then it is loop 3 times into 2, isn't it? If you run third time, then it's a 3 times into 3. So it goes on and on and on. So how many times should we test it? And when should we stop? After, should we test for 100 times? Should we test for, let's say every time we run, it generates some random numbers. So every time the case is different. Yeah. Then there is an infinite number of test cases, right? According to this, you can see sigma 3 into n. There is a totalization of 3 into n, 3 into n, 3 into n, rather going on and on and on. So when are we satisfied to say, should we run 100 times? Should we run 100,000 times? Or should we run 1 million times? So we need to come to a certain limit, right? We should say, right, we tested 10,000 times, we are done. In fact, there is one called Six Sigma method. We will be talking about it later. So where we talk about millions of times, right? So there is a limit there as well. That is actually coming from Motorola component testing. But then are we bringing that to software testing is another matter, but we will be discussing that later. And then what are the good test cases, right? Now we do the testing, but what are the good test cases? So there are different test cases available, and these test cases are suitable and used in different situations. Yeah. So you can't use the same test case everywhere else, right? And if you take software, there are certain software, we call it test suite software. And sometimes they come with built-in test cases, or we might have a library of test cases that we accumulated for a while in the organization. Now, unless it's a fresh company, usual software development companies have their test cases already done. So they might say, okay, we want to do edge testing, we want to do good path, bad path, limit testing, stuff like that. So there may be a set of cases available, but what you're saying here is that all these test cases may not be suitable for all the situations as well, right? There is something called domain knowledge, meaning the knowledge of the area of expertise. Now, if you are building a mobile application for students, let's say student administration. So the domain knowledge is student administration. How about university working? If it is for higher education, if it is for school, you need to have domain knowledge about school administration, right? Not much about the mobile software development, because you're testing the application for the fitness of the domain, right? Can the student use this? For that, you need to understand what kind of things the students are doing. And what are the other people? There are teachers, there are parents, there are administrations. So what do they do? So that is called domain knowledge, right? And domain-based testing is very different to the technical testing. So these are different things, right? We'll be taking each one at a time to talk about these things. Now, a test case. What is a test case? A test case is one question you are asking the software or the program. One question, right? So the test case is the question we are asking, and all we need to do is the software passing that question or failing that question? And then we go to the next test case. So we test the software using test cases, right? One case at a time. So let's say we have 100 test cases, and let's say we have a passing rate of 95%. We need a very tight testing. So we'll say we need a passing rate of 95 test cases, 95% test cases. So we give 100, it passes 95. So we say fine. Or sometimes we say, okay, 80% is okay. Or sometimes we say, no, we need 100%. Depending on the program, depending on the domain. Now, say if it is a health-related application, 100% is required. If it is a defense-related thing, 100% is required. Yeah. If it is a consumer-related thing where there is not much damage, like there is no financial problem or anything like that, then number can come down a little bit, right? But not so much. Maybe 80% is fine, maybe 90% is needed. All depends on the situation, the domain, and all that stuff. That we need to come to some conclusion. Right. The next thing is measurement of testing. Right. How do you measure? Like I said, 95%. So what does that mean? So that means there are 100 test cases. It passed 95 of those. So that is 95%. Right. So as it says, a good project manager wants worse conditions to occur in the very beginning of the project instead of the latter phases. Why is that? Remember, we looked at the chart. We said if you can find the problem in the early stage, fixing that is actually cheaper. Cheaper as in time-wise and also money-wise. If you can't find the problem in the early stage, it gets to the next stage. When it goes from stage 1 to stage 2, it also actually amplifies. So remember, money wise, effort wise, it amplifies. So $1 worth of testing in the phase 1 might be $10 in the next phase. 1 hour of fixing might become 1 day of fixing in the next phase. So you need to, a good project manager wants to find everything as early as possible, right? So next point is very important. If errors are large in numbers, we can say either testing was not done thoroughly or it was done so thoroughly that all errors were covered. Either way, right? If you find lots of errors, it's good and bad. Good, in a way, so that you've done your job very well, right? A lot of testing is done. A bad, maybe in the earlier stage, testing is not done properly, right? So the problem here is there is no standard way other than the numbers that we spoke about. There is no one standardized measure or a unit to say this is a better number, right? Other than the test cases, number of test cases and the pass cases. So you can figure out something for the organization. Now, let's say, depending on the organization, they might have various ways of doing it. So it purely depends on the organization and also domain, plus the kind of software we are building. And each set of these measurement has its value in monitoring, planning, and control. So whatever it may be. So although we don't have a very universal sort of test unit of measure, but whatever that you're selecting can have 4 core components connected, right? 4 core components. So they are schedule, quality, resources, and size. Let's talk about each one. We are testing software, right? So we are trying to come up with a certain unit of measure. So first one is schedule. What will happen when we arrive at the deadline? Because of these errors, will our deadline get extended? Meaning we will not be able to do this, right? Or can we do it faster? Faster meaning your estimation was maybe not correct earlier, right? Either way. What does quality mean? Quality is a very, very important word. Why? It depends on the person who's talking about. It depends on the person who's defining the quality, right? So some people might say, I want 100% bug-free software. That is what I call quality. Some people might say, no, I'm okay for 95%. Some people might say, look, I need to give it to the customer as fast as possible. So I will go with 80%. So the quality depends on the person. And also some people might use a software and say, this is a high quality software. I like the colors. I like the buttons. I like, something. I like it's red and black. Some people might say, "Ayo, this is a boring software. Look, it's only red and white. You are not using all the colors. So this is not a good quality software, right?" Or they might say, "Your button is too big, and I want the buttons to be center line." See, quality is something to do with the person who's using it. So we need to get some standardization from the users also. Number 3 is resources. How much resources are required to develop as well as for testing? Now, if you need 1,000 people for development and 2,000 people for testing, then we have a problem with our money matters, right? The salaries and the time wise and everything else. In fact, if you look at the earlier days, there was the classic examples, IBM 360 mainframe development, software development, 1940s, 50s, I think. There, managers thought if you put more programmers, the software development will happen faster, right? So, meaning add more programmers, like say, for example, if one task requires 1 week or 2 weeks, let's say, you put two programmers, then you can get the task by 1 week. That's what they thought. More resources, faster delivery. Well, it doesn't happen that way, right? Not all the time. In fact, very rarely. And the last thing is size. Size as in anything, number of bugs, number of people, anything for that matter. So these four can be used to help us find a good matrix. Maybe we can look at this approach as well, right? 8-stage approach. Now, this is something that companies use when it comes to figuring out testing, right? So if you notice here, I have a stage and then the purpose, why we have that stage. First is more on the gaining domain knowledge, right? So exploration to gain familiarity with the application. So software team, yes, they are involved from day one, but when the software is developed and given, they might need some time to identify what is going on. So that is exploration. So they need to understand what's going on, what are the screens, what kind of activities we are doing, things like that. Number two is baseline test. A simple, we call it reference test, right? A simple test. So let's say a login system, right? Just to see whether testing process is in action. So for example, you give a wrong email, what happens? Does the system crashes, right? Or you say request password. Does the system crash or it goes on to the next step without crashing? So a baseline is like a very simple test case. Then trend analysis, what does that mean? Trend means you can do some guessing, right, to the future. So you might say, okay, if we do this and this and this as the input, we might get this and this and this as output. So it's actually a kind of a projection to the future. So you can do some inputs and expect certain output and see whether it is working according to that plan, right? That's called trend analysis. To evaluate whether the application performs as expected when actual output cannot be predetermined, right? That means you can't guess the final output, but as in, especially when you are developing the test case, sometimes you can't guess the final output. So there is nothing written in the test plan, but you can test it. Inventory, that is to identify the different categories of data and create a test for each category item. What does that mean? Let's say you want to capture some user information. There may be 4 fields: name, NIC, email address, phone number, 4 items, right? So you need to inventory mean what are the limits of these 4 items? So we take the name. What is the minimum number of characters expected? What is the maximum number of characters expected? What characters are valid? What characters are invalid? And then is the field required field? Can I enter without typing? You know, things like that. And then we have information about this each inventory and also the next one, combinations. For example, name with something and NIC number can be a larger number. So maybe, okay, we can't detect the gender with the name, but if you can couple, let's say there's another question, gender. We can identify the gender with the NIC number as well. So does it work that way? Things like that. That can be another test case, right? And also you categorize this data. Say user information can be one category. Educational information can be another category. So stuff like that. So now by way of categorizing, you can look at the combination of data for testing. So user related data can be tested separately. Let's say admin related things can be tested separately because they are different categories. We also, while developing the inventory, we also need to look at the boundaries. Boundary means data limits, right? Say if it is a date of birth, actually no age, even date of birth, we are looking at 1 to let's say 100. Or if it is a higher education, maybe let's say 15 and above, stuff like that. So we set the boundary. The customer and the developer and the QA staff, they set the boundary so that they can test it. And then dubious data. What is dubious data? To evaluate system response when specifying bad data. So when the system is asking for, let's say, age, we give -5. What happens then? Right? So all in all, our job is to stress the environment. That is to attack the system and break the system. That's the job of the QA staff, basically. Break the system. Because the programmer will never break the system. Maybe, maybe not. They may not evaluate all the test cases, right? So when it comes to knowledge of testing, effective software tester should have these two qualities. Software testing techniques, that is how to test software. There are certain techniques which we are covering and learning in this unit. And number two, application under test. Meaning you must know what the application doing also. Now, let's say you are testing a music player. You should know what is a music player. If you have never used a music player, if you don't know what is music or music play, then you can't test a music player because you have no idea about the music play, right? So likewise, if you are testing an, let's say, accounting package, you need to know somewhat, you don't have to be an accountant, but you must know certain basics about accounting. Only then you can develop the test cases. For example, there cannot be a receipt without an invoice, things like that, logic, right? So if you don't know that, then you can't test business cases. You might be able to test certain technical things, but not the business case. Right, which brings us to another set of slide where we talk about terminology. What is terminology? Terminology is about new terms or new words. So this is the same story as learning a software language. When you are learning a software language, you learn two things. One, you are learning the terminology. You are learning all the keywords, we call it. Number two, you are learning the grammar, or in our case, we call it syntax. How you can put these words together. Right? So here, this is not about development. This is about what are the words used in software testing. This terminology is very, very important. So number one is called error. We also use the term mistake or bug. So be very careful with the words, right? You should be very clear about the difference between error and fault and failure. They are not same. They are different. So an error can propagate. Propagate means they can go from one level to another level. And it's about magnification, right? So as it says, a requirement error may be magnified during the design. What does that mean? We were not listening to our customer. Our customer didn't say that to us. So during the requirement capturing, we did not capture that. When it comes to design phase, that part is not taken. So now it's amplified, right? So the error is a mistake in this case in the SDLC, that is software developer lifecycle. Now that's error. What does fault mean or defect mean? Defect mean a missing or incorrect statement in a program resulting from an error is a fault, right? So result of an error is called a fault, a defect. A fault is a representation of an error. So if error is there, we will have a fault, right? That's what it says. Representation here means the mode of expression, such as narrative text, data flow diagram, hierarchy charts, anything. Defect is a good synonym for fault. Faults can be elusive, they require fixes. So a defect is a better name for the fault, right? And we can fix these things because we know, if we know it's a defect, we can fix it. Failure occurs when a fault executes. You see how it is getting connected now? A failure occurs when a fault executes. So wrong code is getting executed and then it fails. There's a failure now, right? The manifested inability of a system or component to perform a required function within specified limit is known as a failure. How do you know it failed? So evidenced by incorrect output, abnormal termination, or unmet time and space constraints, meaning you type something and you wait and wait and wait and wait and wait. At the end, it crashes. Or it says timeout happened, right? Or it immediately stops when you type something. Or the output is wrong. These are all, we call it failures. Then more words, right? Incident, what does that mean? When a failure occurs, it may or may not be readily apparent to the user. An incident is a symptom associated with a failure that alerts the user to the occurrence of a failure. It is an unexpected occurrence that requires further investigation. So incident means, okay, software may be right, wrong, whatever, it is running smoothly. But when a customer can't proceed, an incident happens, then the customer will start complaining, look, you can't process me. What can I do? Let's say you go to a supermarket and then you're at the queue and then some fault, due to a POS fault, the person can't pay the money. So here we have an incident now, right? Test, as it says, is considered with errors, faults, failures, and incidents. So test is an act of exercising software with test cases, right? There are test cases. You run the software with the test cases, expecting it to fail, right? So there are two things here when it comes to testing: to find failures and also demonstrate correct execution. So testers can show both. Testers can show, okay, this is working properly, or you can say, okay, this requires test fixing. Then what is a test case? Each test case, by the way, has a unique identification, right? And it is also connected to a certain program behavior. Then only we can come back and say, right, test case number 562 failed during this input, and this is the output we receive. So then we can assign that to the person who wrote the code. So each test case has an identification. It also has certain inputs and expected output, right? So our job when it comes to software testing is to write the test cases, as many as possible. That's the main job of the software tester. Now, how does a software testing document look like? Okay, here's a sample. So this is a sample for one test case, right? So you can see test case ID, purpose of the test case. What are the preconditions? What does that mean? Pre means before. So before you conduct the test, these are the things that must be there. Those are called preconditions. So if you want to test it, you need to make sure the preconditions are properly put in place. Then what are the inputs required for this test? It may be numbers, names, whatever. And then expected out. Okay, after you give this input, what is the expectation? What should come? Right? And also post condition. What does that mean? After you run the test, what should have happened to the system, entire system? Let's say we add a new student to a student administration system. The student count should be showing that. And if you look at the class numbers, student numbers, that student should be there in that class. So those are the expected outputs. I mean, post conditions. After that, what do we do? We run the test case. Right? Now, the bottom shows what happens then. When did we run the test? So it's usually a date stamp. And what is the result we receive? So we need to compare that with the expected output. And then sometimes the software might have a certain version number. So it might have version 1, 2, 3, 4, whatever. Or when it comes to test case, we run test cases multiple times, right? So we can say test case version 1. Same test case, we run again when the software developer says, right, I fixed it. We don't know. We need to run the same test case again. So then we change the version now. And the last one, of course, is the name of the user who ran the test case. Right? So this is a sample test case. I mean, test case document. Let's look at a real test case. This is for an ATM, yeah? So the precondition, before starting the test, precondition is system is started. So ATM is now running. We can't test it on a dead machine. So we tell, right, for us to test it, this is the precondition. So as for the precondition, it is running. If you look at carefully, you can see test case ID session 1. Test case name, verify card. Then there are, of course, 2. Verify card on the top. Next one is validate PIN. Test case description, to verify whether the system reads the customer's ATM card. So what are the steps? Insert a readable card. Card is accepted, system asks for entry of PIN. Otherwise, insert an unreadable card, card is rejected, system displays an error screen, system is ready to start a new session. Right? So as you can see, there is actual test and test status, pass, fail, and then test priority. Now the priority is about which test we run first, which test we run afterwards, which test we run last. Right? Here are more things we can discuss. Session 2, validate user sessions. So verify card, validate PIN. Then comes the next big one, validate user session. Now here if you notice this system asks whether customer wants another transaction. The system displays a menu of transaction types. Is another one. Verify transactions. Right. So if it is a processing large number of, let's say, money dispensing and deposits, because it's an ATM, we need to verify each one, right? So again, what we do under that. Okay. So this is an example of how a test case look like. So who's writing this? The tester. The tester's responsibility is to develop test cases so that testing department can use these test cases now and also later. Right, which brings us to the further terminology. So we've been looking at terminologies. What is a test suite? as a word says, test suite is a collection of things, right? A collection of test scripts or test cases, anything. It can be the private property of the organization, or you may be getting from other people to find out how they test their systems, right? So it can be testing a logical or a physical area of a product. Right? And then test script. What does that mean? This is basically a step-by-step instruction that describes how a test case is to be executed. Right now, this may be to the developer, human developer, or the computer also. Now, sometimes we have something called the automated testing. So there we have to write the scripts to the program saying, look, you need to go to this URL. You need to enter the username here. You need to enter the password here. So we need to basically record these things step by step and give it to the either the automated testing program or a human to run the test. Right? What is testware mean? It's like software testware. Okay. So this testware, there are two things. One is we develop the test plans and documentation before the test begins. Number one. Number two, you get the results after you run the test. Okay. So that is called testware. And okay, here's an interesting another terminology. Oracle. What does that mean? Test oracle. Generally, oracle, actually, I think it's a Greek word. Oracle means you are asking the experts, right? The specialist. They said the specialists were living in a cave called oracle, yeah, or the people were called oracle. So you go and ask them, why are we not getting rain? Why is it night dark in the night? Stuff like that. So here, similarly, oracle is like a knowledge base where um, we can sort of predict certain things when you run the software. So now, of course, that requires a lot of experience and things like that. But we can somewhat predict what should come at the end of it, right? When you run certain things. Say, for example, you are doing a face recognition software algorithm. So you sort of have an idea about okay, how it should work, right? So you compare that with what is coming after. We also have another term called the test log. Now, if you remember the document right here, this is a document, right? And you write the results after you run the document, after you run the test. So these logs must be available throughout the program. So if anyone wants to come back and check it later, they have the logs, right? Now, generally, these are documents that you store in a archived place. Normally, we don't print it, but anytime you want to, you should be able to go and get that. And then the report. This is generally the last sort of document that we generate. It's kind of a summary. If they want details, we can say, okay, go and check the detail. But in the test report, we give a good summary of what happened. Like how many, most of the time, it's a quantitative report where you give numbers. We say a program had 500 features. We tested each feature with 10 cases, and here are the results, right? So something like that. Remember this V-shaped SDLC cycle from last week? If you notice carefully, there are left and right. There are two sides, right? On the left, you can see we start from requirement spec, design, and coding. So prime target to introduce errors. Errors to the design spec, errors to the requirement spec, errors to the code. Three critical places where we might get errors so that, our software is faulty. And the only way to find out is to test. So that's why the test is in the middle. And if you don't test properly, the incidents will go unnoticed. Right? We want incidents as much as possible. So when we do our test, we keep telling the programmers about the findings coming up. They might not fix it immediately, but they'll accumulate certain things, and then they might release something called the technical term is hot fix. And then when you put together a bunch of hot fixes, it becomes an update, right? So like you notice, Microsoft, Adobe, many other softwares, they say, please download the update. That means they bundle various things. So before we go to the incident, they fix the problem. So left-hand side is introduction of bugs. Right-hand side is fixing the bugs. Right. So if you look at the life cycle of software development, right? We looked at, we didn't discuss a lot, but we know there is SDLC waterfall method, and there is agile method. There are also others like extreme programming and so many other things, but those are like the things out there. But same story applies to testing life cycle as well, right? So if you notice on the left-hand side, we are giving the bugs to the system, but on the right-hand side, we are getting the bugs out, right? Now, there is a last point which we didn't bring under the terminology. Deficient. What does that mean? Deficient. Deficient means software was working perfectly, and then it went through a bug fixing. And after the bug is fixed, there's a new bug that is introduced. So that is called deficient. Right, which brings us to some colorful slides. Software testing life cycle. Now we looked at SDLC, software development life cycle. Here comes the software testing life cycle, right? It's a series of particular tasks carried out throughout the testing process to guarantee that software quality objectives are accomplished. So there are 6 here. Number 1 is requirement analysis. Now, by the way, we are talking from the point of view of testers, okay? So requirement analysis, we as testers, we need to be part there as well. Number 2, once we understand the requirement, we start immediately designing the test plans. We will not wait for the developers to get the code up. We start developing the test plans. And then while you're at it, you also need to look at test case design and development. Remember, it's not just a simple task to design a test case. So we need to understand what is going on there. Once you are ready there, you need to set up something called the test environment. What does that mean? Let's say the program is a desktop. You need to then need a computer that can run the same software. Or actually, you should have the same sort of hardware environment as the custom. And they try to install it there. Let's say, for example, customer has Java version 8, you are running 22 version. And the application is developed using, let's say, version 21. So now it might work on your computer, but not on the client's computer. So we try to get the environment as close as possible to the customer. Right? That's number 4. Number 5 is, you remember we design some test cases. Number 5 is run the test cases. Right? So, okay, the last one says cycle closure. So it's coming back to the step 1. Now, we also noticed earlier, according to that formula, testing is endless, right? So we can't test until all the defects are unearthed and removed. It is simply impossible. So we need to figure out, okay, we are going to live with it, and how long we have time to test it. Yeah. So the question is when? What is a tolerable number of bugs that we can have? For example, Windows has a very interesting tendency of releasing the software even with bugs, right? Of course, it first comes to the alpha testers or users who are internal to Microsoft, and then it goes to the beta testers who are outside Microsoft, but they are partners of Microsoft. And when the beta is also, when they receive enough complaints or testing case studies and whatnot, they can then go to the next level, fixing them and sending another release. Now, what do you mean by trade-off? Trade-off means there is something on the left, something on the right. So when you pull towards left, you're going towards left, but then the right-hand side also getting sort of dragging onto you. So it's a trade-off, we say. Trade-off meaning when you pull from one side, the other side goes away. So trade-off between budget, time, and quality. So you can't have a, let's say, cheap product, very high quality cheap product, or you can't have a very high quality product without spending a lot of money, right? So that's why these three are connected. So the point here is it's driven by profit models. That's the sort of the question we have. Then we have pessimistic and optimistic view. So the pessimistic can negative mean is to testing whether some or any of the allocated resources are exhausted. So like we're given some resources, are they still there? Are they exhausted? Optimistic is to stop testing when either reliability meets the requirement or the benefit from continuing testing can justify the testing cost, right? So how are you stopping, right? That's what we're talking here. The optimistic stopping rule is to stop testing when either reliability meets the requirement, meaning we say our software should work without crashing for 10 days heavily. So if you achieve that, then sort of okay with the client. Then when you have another bug, maybe you will fix it later. Which brings us to the next topic, principles of testing, right? Now, as it says, testing should be based on user requirement. Remember, we spoke about it. You go to the customer, find out what do you want, right? And then testing must support that. This is in order to uncover any defects that might cause the program or system to fail to meet the client's requirement. Then testing time and resources are limited. Because of that, we need to have certain timeline to stop our testing. So avoid redundant tests, meaning sometimes you don't need to test again and again and again. You test 10 times, 100 times, maybe it's okay. Exhaustive testing is impossible. As stated by Meyer, it is impossible to test everything due to huge data space and the large number of paths that a program flow might take. So exhaustive testing meaning there's always a limit. You can't be continuously test, right? Because that also generates lots of log files and other data files. So it might be an issue. Use effective resources to test. What does that mean? You can test everything manually, but then humans have a limit, isn't it? We can't be testing everything all the time. So we need some help, either from software or other people, whatever it may be. So we'll look at some software later. So DJGNU is a very famous one. It is designed for regression and embedded system testing. Regression meaning like when you change something, you want to test again and see whether the system is behaving just like before, right? And the last point here is very, very important. Test planning should be done early, right? That's very important. Right. Further pointers. Now, Just like building a house where we start with one brick at a time, testing also goes on with one step at a time. And then from brick to brick, we start building the walls and then the house and then maybe, the cathedral, the large construction. Same story here, right? In fact, we'll go down to a very interesting concept called TDD, test-driven development, where even the feature or actually function is testing. So you don't write the function, you write the test first. That's why we call it test-driven development or test-first development. Yeah. So when we do that, then it's simple, isn't it? So you start small and then you keep building and building and building and building. You expand it further. And then all actually, second point, testing should be conducted by an independent third party. Now, what does that mean? Well, it doesn't mean people outside the organization. Sometimes we do that also. Especially, let's say, software that is involving money or health or something. Then we get a third party consulting company to do the testing as well. After we conduct our own testing, we give it to an outsider to test it also. It's very expensive, but many companies do that. In fact, the customer might say, look, we can't believe you tested it, so give it to, let's say, Arthur Anderson or PricewaterhouseCoopers or whatever company. Let them test it. They are globally known for proper testing. And if they say, okay, we will buy the software, right? And the third point is all testing actually should be leading to customer requirement. Now, this is also a bit of a question mark. Now, customer may have not told us what they want exactly. So we may have not tested it. Say, for example, customer may have not told us that they will go up to million customers, million users. So we have never tested 1 million users before. So, things like that. So whatever we are doing, or maybe we are testing 1 billion users, but customer says, look, the maximum is I'm getting 1 million. So then we can cut down a lot of expenses without testing for 1 billion. And that's why you're saying every test should trace to the final customer. Next one is interesting. Avoid programmers. Don't take programmers as testers. Why is that? Well, I suppose you shouldn't take the programmers who wrote the same code. You should get programmers from other departments. That's okay. Because people who wrote the code will not write the worst case scenario or the mistake. So, for example, if it asks for an age, they will never think of typing -5 or 120 or 200. Right? They'll type exactly the right answer. So that way we will not be able to test the edge numbers. So technically, people who wrote the code shouldn't be in the testing team. And look at the next one. Test should be planned to show software defects and not their absence. Now, this is a very big one. We write or we test software not to say, look, everything is fine. Yeah. We need to show there are certain defects. Right? That's why we plan the test plan. And then the report should include the test cases and test results to summarize the result of testing. So someone looking at the test report later should be able to understand why the testing was done, how the testing was done, what are the results, inputs, outputs, all that. And then advanced test planning is a must, meaning go back to the BA stage. Sit with the BA, sit with the programmers from day one and then plan it. Only then we should be able to get a proper testing done. How about this one? Software testing is an art, right? So it's not engineering, it's not numeric, it's an art. Good testing also requires a tester's creativity, experience, intuition, together with proper techniques. So intuition is what? In Sinhalese we say iva. We can iva thina කියලා. හරියටම explain karan be now then I know I'm see there. So we feel something, we can't explain. That's called intuition, right? So you should have creativity, experience in testing. Okay, that we can get later as well. And then intuition. And you must know the testing techniques. If you don't know testing techniques, you can't do that as well, right? Now, here's another method of testing, right? This is called the PDCA cycle. PDCA stands for plan, do, check, act. So first, you develop a strategy to resolve the issue at hand. That's called planning. So if you're going to do a software testing, okay, so where do we start? Number two is do it. Execute your action plan. So you run the plan and record everything. Whatever that you're getting out, you record it. And then check against your plan. So you were supposed to get number 5, you're getting number 6. Are you recording it? Yes, you have to record. You're expecting 5, you got 5. Are you recording? Yes, you have to record. Right? So you check it against your actual data output versus what is there. And then you act on it. If it is a mistake or a defect, you need to inform the developers and then get another cycle done. If everything fine and passing, then you need to inform them, look, okay, out of my 100% test, all 100 are passed. So whatever it may be, you act on that. So this is called the PDCA cycle, very famous when it comes to not just software testing, but anything that matters. I also got this very interesting slide that says 7 reasons why software testing has a bright future. Some people think, okay, AI is here, so there's no job for us. There's no point of doing software testing. Not really, right? If you have an idea about AI and ML, yes, you can be a great tester, right? You can use AI to do your job fast, not to get AI replace you. You can do AI to do the testing much faster than before. So isn't it much better? Won't the company need someone or immediately attract someone who's a tester with AI knowledge? Of course, they like it, right? Shift left testing. What does that mean? Left means earlier. Left-hand side is where you start things and right-hand side is where ending things. So shifting towards left. So you not only test things, you're also getting into stuff like, business analysis, planning, stuff like that. So you learn a lot more. And also there are certain things like DevOps testing, big deal nowadays. DevOps are the people who know development and also networking and operations side. So testing is a huge role there. There is something called CI/CD, continuous integration, continuous delivery system. So their testing is paramount. You have to know, especially automated testing, because you don't do manual testing there. And then we'll be learning under software development and engineering something called agile testing, right? Where it's very dynamic. You don't wait till the end of the cycle. You immediately go through the development team on testing. And then there are mobile testing, IoT testing, blockchain testing. There are so many things out there in the market. So if any of you are planning to have a career in testing, there's a huge demand there. So don't worry about it. There's a huge demand for testers. This is another basic one which I thought may be interesting. What kind of software testing available there, right? Regression testing, unit testing, functional testing, integration testing, and then there is acceptance testing or UAT. That's a very famous one. Like you develop the software, you test everything is right, and you're about to give it to the customer. And then you say, customer, please do a UAT. You say acceptance testing. After they do that, then you can commission the software. Then performance testing, security testing, and then stress testing. These are different kinds or different types of software. Some companies do everything, some do many, but they all must do something. They can't say we didn't do any testing. They have to do that. Now, talking of software test engineers, there are 3 sort of kinds we can look at. Yeah. Test engineer, QA engineer, and then SDET engineer, a software engineering test, right? So design test method is the first one, test engineer. So develop the test methods and also look at performance. Now, performance is a big one. This is very statistical thing. Yeah. So test engineer will give statistical report about the fitness of the software. So that's a testing. What is QA then? Quality checks and quality control. Probably language, the fitness of the UI, verification, validation side. If the organization has like ISO something, are they fit for that? So basically, is it going according to a certain specification? That's QA, right? So the last one is responsible for designing, development, and testing, right? So there may be developers, also testers. Now, if you remember, in one point, we said don't involve developers in testing, but there may be other areas like, say, TDD, for example, where the developer is also a tester, at least in the coding wise. Right, another interesting one. Okay. What are managers looking for when hiring testers? So these are some of the skills we need to master if you want to become a good tester. More emphasis on test automation and coding abilities. So if you know coding, then you can go into the white box testing, right? Rather than black box testing. And you can also do some automation. So those are huge plus points when it comes to hiring. Self-learner, meaning you have a knack of learning. So you want to go learn. There are other people who just finish a degree, they don't upgrade their skills at all. Just do any job coming their way. But they'll be looking for someone who continue to learn new things. Programming skills and product business thinking. So remember the BA side, that's what you're talking about. Problem solver, multitasker, team player, assertive and creative thinking, enthusiasm, front-end experience much more than the back-end, because especially when you're testing the user side. Good communication skill, emotionally intelligent. Emotional meaning, you see, QA might get a lot of blame from the developers saying, look, you're finding our faults. Of course, that's your job, right? And we are saving the company of shame if the product goes out to the customer, and if customer finds out the problem, we will get into serious trouble. So you need to be emotionally fit to face these things. And then load testing and security testing knowledge. Load meaning like how much load the software can take. Let's say users. Is it 100 users or 100 million users? And then how do you test that? You can't hire 100 million people to test one software. So obviously you have to automate it, right? So proactive problem solving and also technical knowledge. If you're into IoT stuff, then, of course, we need that knowledge as well. Automation tool experience, coaching and leadership. That means if you're going up, you should be able to train other people, other juniors. And then agile is a big deal nowadays. We must know what is agile. Actually, agile doesn't come under SQA, but you will have other sections like software engineering where you'll be learning agile. And last line, adaptability and flexibility. Experience with CI/CD. Remember that I spoke about? And the last one, puzzle solvers. See, the QA guys, they are solving puzzles, isn't it? So they need to know what questions these people are solving. So puzzle solving is excellent skill when it comes to hiring. Right. So that essentially brings to end of the presentation. Let me take you quickly through the website. Right. So here's our LMS page. So if you go down to week 1 here, I've uploaded the books, right? This is a very good one, Concise Guide to Software Engineering. And then, so there is a recorded lesson here, the video, and also some cases where failures happen because of bad testing, right? These are YouTube videos. If you go there, it will give you some information, and then the video link here. And now you saw also for last week, I updated the slide presentation and then the recorded lesson here. For this week, I've got the presentation and also two very good articles. So one is software testing explained in 100 seconds. Very interesting video clip. Now this one is also interesting. This is actually US Association, American Software Testing Qualification Board. So if you go here, it also has lots of videos about testing qualification, right? And on the right-hand side here, lots of testing specifications. Say, for example, if you want to become a game tester, what do you need to do? Or you want to become a mobile application tester, what do you need to do? Right? So it's a global qualification, by the way. They also have various things. So if you go to foundation level, I'm showing this in case if you want to build your career on software testing, right? So there are some videos and there are study materials, right? PDFs and lots of stuff. Right? This is a complete syllabus as a PDF document. Sample exams are there. Lots of different things here. Right? So at the end, it's a 40 questions in 1 hour. In case if you're interested in building a software testing career. Right? And also, there are other things I'm adding. So just go check out the LMS time to time. I'm adding interesting stuff. So they're not very long ones. So you can also have a look at it. So this is another interesting video clip, software testing explain how QA is done today. So it talks about the history and then also what is actually going on right now. And this is the very famous 10-minute test plan by one of the Google chief architect, James Whittaker. Superb document. So he had a chat with his team about how to develop a very short test plan. And that became an instant hit around the world. So you can read that article here. All right. Any questions, anybody?